আমরা rectangular coordinates chapter এর article number 8 শুরু করতেছি, which is projection of broken lines, that is consisting of several continuous segments. These segments are PQ, QR and RS. The projection of PQ is P1 Q1 on the line LM. QR, projection of QR is Q1 R1 and projection of RS is R1 S1. If we join the point P and S by line PS, the projection of PS, projection of P is P1 and projection of S is S1. So that the projection of PS is exactly P1 S1. The projection of PQ is P1 Q1, projection of QR is Q1 R1, projection of RS is R1 S1. The lines PQ, QR, RS not lying on the same plane. These three broken lines are in space. তাহলে আমরা তিন broken lines তাদের projection একটা নির্দিষ্ট লাইনের উপর নিচ্ছি এবং ফার্স্ট আর লাস্ট পয়েন্ট জয়েন করে যে লাইনটা পাচ্ছি তার যে প্রজেকশন সেটা হবে আমাদের ওই ব্রোকেন পার্টস যে তিনটে আছে তাদের প্রজেকশনের সাম, দ্যাট ইজ প্রজেকশন অফ PQ প্লাস প্রজেকশন অফ QR প্লাস প্রজেকশন অফ RS ইকুয়াল টু প্রজেকশন অফ PS. এটা হচ্ছে আমাদের মূল ইয়েটা। এটার রিলেটেড যে ফিগার সেটা আমরা এখানে এক্সিস হিসাবে দেখাচ্ছি। OP is a line whose coordinate is x, y, z, so that the points x, y, z can be taken as Pn, this is the figure. Projection of PQ, sorry OP, projection of OP can be taken as the sum of the projections OA, AN and NP. OA is distance OA is equal to NB, which is x. AN equal to OB equal to AN equal to OB equal to y, and PN is equal to OC, which is z. These three distances, that is coordinates x, y, z, are the projections of OP on x-axis, y-axis and z-axis. These three are the broken parts of OB, similar to this. Now the broken parts OA, OB and OC, taking the projection of OP on another line whose direction cosines are known. say OL is a line, the direction cosines of OL are L, M, N. Here we take the projection of OP whose both endpoints O and P are known. P is XYZ, O is 0, 0, 0. OL is another line on which the projection of OP may be taken. The direction cosines of OL are L, M, N. আমরা যদি কোনো একটা লাইনের প্রজেকশন অন্য একটা লাইনের উপরে নিতে চাই, যে লাইনের প্রজেকশন নেব তার দুই এন্ড পয়েন্টসের কোঅর্ডিনেটগুলি জানা থাকতে হবে, এন্ড যে লাইনের উপর প্রজেকশন নেব তার ডিরেকশন কোসাইনগুলি নোন থাকতে হবে। এটাই আমাদের নিয়ম। তাহলে আমরা ওপি এর প্রজেকশন নিতে গেলে ওপি এর যে ব্রোকেন পার্টসগুলি, দিস আর দি ব্রোকেন পার্টস অফ ওপি। These are broken parts of OP. The broken parts of OP are X, Y, Z, and the direction cosines of OL are L, M, N. The projection of OP on OL is the sum of projections of broken parts of OP, that is X, Y, Z, on the line OL. Therefore, the projection of OP is exactly difference of coordinates x minus 0 into direction cosine L plus y minus 0 into M plus z minus 0 into N, which is exactly x into L, y into M plus z into N. This is the projection of a line through the origin OP of projection of OP on OL. This thing is projection of broken lines. এটা আমাদের জেনারেল আলোচনা। ফার্স্ট আর্টিকেল যেটা করলাম সেটা হচ্ছে আমাদের 1, that is projection of a line OP on another line OL. This is XL, YM, ZN. And 2 is another sub article বলা যায়, another sub article to projection of a line joining 2 points on another line. Here the line AB is the line joining 2 points x1, y1, z1 and x2, y2, z2. The projection can be taken on another line whose direction cosines are known. AL is a line whose direction cosines are L, M, N. Shifting the origin from the point O to the point A, x1, y1, z1. The new axes ax prime, ay prime, az prime are new axes, so that x1, y1, z1 is 0 in that case. So that with respect to new axis, the point B, coordinates of B becomes x2 minus x1, y2 minus y1 and z2 minus z1. These are the coordinates of B with respect to the new axis. Now, the projection of AB means the broken parts of AB, x2 minus x1, y2 minus 1, z2 minus z1. If we take projection of AB on AL is sum of the projections of x2 minus x1, y2 minus y1 and z2 minus z1. Projections of x2 minus x1, y2 minus y1, z2 minus z1 on the line AL. Having DCS are L, M, N. Therefore, the projection is x2 minus x1 into L plus y2 minus y1 into M into N. This is the projection of a line joining 2 points on another line having direction cosines L, M, N. Article 9, angle between two straight lines. Let us take two lines OP1 and OP2 which are parallel to two another given lines. Let P1 coordinates of P1 and P2 are x1, x2, x3. Sorry, coordinates P1, x1, y1, z1 and P2 is x2, y2, z2. Distance OP1 is r1, OP1 is r1, OP2 is r2. The direction cosines of OP1, OP2 are L1, M1, N1 and L2, M2, N2. The coordinates of P1 and P2 are these. We know that the relation between direction cosines, coordinates and distance, x1 equal to L1 r1, that is L1 is x1 by r1, so that x1 equal to this, y1 equal to m1 r1, z1 is n1 r1. Similarly, x2 y2 z2 are l2 r2, m2 r2 and n2 r2. Let theta be the angle between OP1 and OP2. Therefore, taking P1n a perpendicular from P1 to OP2. Now, ON is a projection of OP1 on OP2. Projection of OP1 on OP2. That is, when become ON equal to OP1 cos of theta equal to OP1 means R1 cos theta. Also, when is the projection of OP1 on OP2? When is the projection of OP1 on OP2? This is relation 1. Again, when equal to projection of OP1 x1 into L2, projection of OP1 on OP2. P1 এর কোঅর্ডিনেটস এবং ডিরেকশন কোসাইন অফ OP2 প্লাস y1 into m1 m2 when is r1 cos theta equal to x1 means L1 R1, y1 is m1 R1, z1 is n1 R1. R1 into L2 plus m1 R1 into m2 n1 R1 into n2 or R1 cos theta equal to R1 is common, L1 L2 m1 n2 m2 n1 n2 as R1 is OP1 which is non-zero, so that if we cancel R1 from both sides, cos theta becomes L1 L2 plus m1 m2 and n1 n2. This is the angle between the two lines in terms of cosine of the angle. This is 2. But sin theta is, or sin square theta is 1 minus cos square theta. This equal to L1 square, M1 square, N1 square is 1. Also L2 square, M2 square, N2 square is also 1, minus cos theta L1 L2, M1 M2, N1 N2 whole square. If we simplify this, equal to M1 N2 minus M2 N1 whole square, N1 L2 N2 L1 whole square, L1 M2 minus L2 M1 whole square. This is sin square theta, so the sin theta is square root of that. Therefore, sin theta equal to M2 N1 whole square, N1 L2 N2 L1 whole square plus L1 M2 minus L2 M1 whole square to the power half. This is sin theta is 3. Quantity is a number which must be less than 1. This is also less than 1. Theta equal to sin inverse of that. আমাদের অ্যাঙ্গেল মোটামুটি বের হয়ে গেল। এই দুটো রিলেশন থেকে আমরা কন্ডিশন অফ প্যারালালিজম এন্ড পারপেন্ডিকুলারিটি সেটা এরপর আলোচনা আসতেছি আমরা। পরবর্তীতে পার্টিকুলার কেস 1 কন্ডিশন অফ পারপেন্ডিকুলারিটি, এরপরে 2 নাম্বার আমরা কন্ডিশন অফ প্যারালালিজম দুইটা আসবো। এখন আমি কন্ডিশন অফ পারপেন্ডিকুলারিটি কিভাবে পাচ্ছি সেটা। If the straight lines are perpendicular to each other, then theta is pi by 2. Therefore, from 2 cos theta is cos pi by 2 equal to L1 L2 M1 M2 N1 N2. Or cos 90 is 0, 0 equal to that is L1 L2 M1 M2 N1 N2 equal to 0. This is the condition of perpendicularity between two straight lines. Two dimension আমরা একই ধরনের A1 A2 B1 B2 A1 A2 plus B1 B2 equal to 0 এটা পেয়েছি আমরা টু ডাইমেনশনে সিমিলার টু দিস, এটার সিমিলারিটি হচ্ছে এটা। এরপর হচ্ছে আমরা কন্ডিশন অফ 2 condition of parallelism. if the straight lines are parallel, then theta is 0 or pi, so that sin theta is sin 0, which is 0. Sin theta is m1 n2 m2 n1 whole square, n1 l2 n2 l1 l1 m2 l2 m1 whole square to the power half is 0. That is sin theta. Sin theta is 0. From this we can write m1 n2 minus m2 n1 whole square plus n1 l2 n2 l1 whole square l1 m2 minus l2 m1 whole square equal to 0. We know that if sum of 2 or 3 or more than that, sum of square which are always real numbers be 0, then each of the terms must be 0. Each of the term must be 0. Therefore, m1 n2 minus m2 n1 is 0, n1 l2 minus n2 l1 is 0, and l1 m2 minus l2 m1 equal to 0, or m1 by m2 equal to n1 by n2. Also, n1 by n2 is l1 by l2, and l1 by l2 equal to m1 by m2. From these relations we get therefore l1 by l2 is m1 by m2 equal to n1 by n2. This can be written as a square root of l1 square m1 square n1 square l2 square m2 square and n2 square to the power half, that is equal to 1, or L1 is exactly equal to L2, M1 equal to M2 and N1 equal to N2. If the straight lines are parallel to each other, then the direction cosines of two lines must be equal, as sum of the square is 1, this is also 1, total result is 1. So that L1, L2, M1, M2, N1, N2 are equal. Yes. Particular case 3, if the direction ratios of two lines are known, then find the angle between the straight lines, between the two straight lines. Sorry. Solution: let A1 B1 C1 and A2 B2 C2 are the direction ratios of two straight lines, then their direction cosines are L1 is A1 by summation A1 square to the power half, M1 is B1 by summation A1 square to the half, and N1 is C1 summation A1 square to the power half. Also L2 A2 by summation A2 square to the power half, M2 is B2 by summation A2 square to the power half, N2 is C2 by summation A2 square to the power half. These three are the exact direction cosines of the lines. Therefore, the relation or relations cos theta is L1 L2 M1 M2 N1 N2, and sin theta is M1 N2 M2 N1 whole square N1 L2 minus N2 L1 whole square, and L1 M2 minus L2 M1 whole square to the power half. এই ফর্মুলা আমরা আগে ইউজ করছি ডিরেকশন কোসাইনের জন্য। যেহেতু আমাদের এখানে ডিরেকশন রেশিওগুলি জানা আছে, তাদের থেকে আমরা ডিরেকশন কোসাইনগুলি বের করে জাস্ট এই ফর্মুলাতে মানগুলি বসাই দিচ্ছি। cos theta becomes L1 L2 M1 M2 N1 N2, that is A1 A2 B1 B2 and C1 C2 whole divided by summation A1 square into summation A2 square whole to the power half. অর্থাৎ আমরা L1 M1 N1 L2 M2 N2 এই মানগুলি জাস্ট আমরা এই জায়গায় বসাইলাম। L1 into L2, that is A1 into A2 divided by এই দুইটা, নিচে আমাদের এগুলি কমন। দিস ইজ cos theta। and sin theta becomes B1 C2 minus B2 C1 whole square C1 A2 minus C2 A1 whole square and A1 B2 minus A2 B1 whole square to the power half. These are the angles in terms of cosine and sine. Now this divided by summation A1 square summation A2 square to the power half একসাথে আমরা দিয়ে দিলাম। This is sin theta. From these two formula cos theta and sin theta, we can found the condition of parallelism, perpendicularity both. Condition of perpendicularity. Condition of perpendicularity, that is theta is 90 degree. Pi by 2, so that cos theta is cos pi by 2 equal to 0, or a1 a2 b1 b2 c1 c2 by summation a1 square a2 square to the half equal to 0. Denominator is non-zero, numerator is 0, or a1 a2 b1 b2 and c1 c2 equal to 0. This is the condition of perpendicularity between two straight lines when the direction ratios are known. And condition of parallelism. Condition of parallelism, here theta is 0 or 180 degree. So that sin theta is sin 0, sorry. Therefore, sin theta is sin 0 or sin pi, which is 0, or b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square and a1 b2 minus a2 b1 whole square is 0. Denominator is non-zero. From this we get b1 c2 minus b2 c1 equal to 0, c1 a2 c2 a1 equal to 0, a1 b2 minus a2 b1 is 0. From these three relations we will get a1 by a2 is b1 by b2 equal to c1 by c2. But a1 square b1 square c1 square is not equal to 1, so that we can't proceed this a1 by a2 b1 by b2 c1 by c2. In two dimension this condition is a1 by a2 is b1 by b2 in two dimension. Similar to this in three dimension. Rectangular coordinate চ্যাপ্টারটা আপাতত এখানে শেষ। আমরা পরবর্তী প্লেন চ্যাপ্টারটা শুরু করব।